Okay, in this video, we are continuing assignment 5 from my Calc CD class. It's about evaluating iterated integrals, which are just double integrals. In this case, the integrand, h of xy, will not be equal to f of x times g of y, so we're going to have to be a little more careful, and we're still going over a rectangle. Let's take a look at the problems. So, number 27, we are going from 0 to 1 and then 0 to 2 of x plus 4y cubed dx dy. So you look at that and you notice it is not possible to write that integrand as some function of x times some function of y. So we can't use that trick where we separate it into two integrals and just multiply them at the end. Instead, we're going to have to actually do it, which in some ways is almost easier conceptually because it's more like what you did in like Calc 1. So we're just going to look at everything, decide what's a constant and what's a variable, and integrate. So first up, we look at this and we see that our inner integral is in terms of x, right, because of dx. So all of the x's are variables, all the y's are constant. So that 4y cubed might as well just be like 4, right? And if you integrate just 4 with respect to x, you would get 4x. So in this case, we'll get 4y cubed times x. But also the integral of x is 1/2 x squared. So we get 1/2 x squared. Then plus, you'll have your 4y cubed, and then times x, because x is the variable. All right, and then we're going to evaluate this for x values. So x goes from 0 to 2. So this is more important here than it was in the previous video, the previous parts, because now we have multiple variables still hanging around, and you got to keep track of what you're subbing for. I'm using color coding, so it's a little easier for me, but in the real world, when I do these problems, I don't color code them. This takes forever. And I don't really recommend it. Although I kind of do recommend it if you're doing a small number of these. It's great. It will really help you to figure out what's going on. We still have a dy hanging around. All right, we evaluate the inner integral using a fundamental theorem. So we plug in 2 for x, and then we plug in 0 for x. People handle this in different ways. I'm going to do like this first part as if it's its own thing. So we'll get 1/2 and then 4 minus 0, and then we'll have plus 4y cubed, and then 2 minus 0, right? So x, we're plugging in 2, then we're plugging in 0, we're subtracting. So we get this. So now we have just an integral with respect to y, and the only variable that I should see is y, because there's only one differential left, right? There's just dy. So this cleans up to this. And then we integrate with respect to y, so plus 1 times the reciprocal in all cases. You plug in 1, and then you plug in 0, so you end up with 2 plus 2 minus 0, so we get 4. All right, carrying on. Again, so it's 0 to 2, 0 to 2. X squared minus y squared. There is no way to separate that into f of x times g of x. It's more common not to be able to separate it, I would say, for these types of integrals. So be on the lookout for it, but don't expect to see it. So the inner integral is in terms of y, right? It's dy. So we are going to integrate with respect to y. So x squared is a constant. Integrate a constant with respect to y. You just get that constant times y. So it'll be x squared times y. And then minus 1/3 at y cubed. Now we're going to stipulate, not speculate, that we're plugging in y equals 0 and y equals 2. You will avoid mistakes if you do that. Not everyone does it. I can't force you to do it, but it's a really good habit to get into. All right, so we evaluate. So remember, we're plugging in for y, so we'll have x squared and then 2 minus 0. Then we'll have minus 1/3, 2 cubed, which is 8 minus 0. Okay, so this, when we clean it up, gives us this integral. Now we're just doing a Calc 1 integral, so reversing the power rule, plus 1 times the reciprocal, gives us this. Evaluating gives us this. And then ultimately we get 16/3 minus 16/3, which is 0. Could we have known that going in? If you have a very good sense of what surfaces look like, which I definitely don't, you could have known that this was going to give us 0 because of the bounds and the integrand. I wouldn't have seen it until I got the answer, though. All right, 29. From 0 to 4, 0 to 9, square root of x plus 4y dx dy. All right, so the first differential we run into, the innermost, the most nested of the integrals, is with respect to x. So I'm going to think of it, because I do not like integrating radicals, I'm going to think of it as x plus 4y to the 1/2. So it's plus 1 times the reciprocal. X is the variable. If y was the variable, we would have some chain rule stuff to deal with, but y is not the variable. X is the variable to begin with. So there's no chain rule to deal with. You just, plus 1 is 3/2, the reciprocal is 2/3. So we are going to get 0 to 4, 2/3, and then this thing to the 3/2. And then we're going from x equals 0 to x equals 9. And then we still have a dy. Okay, so then we're going to sub in for x, which again, because I'm color coding, is kind of easy to tell, but you really got to keep track of these things. I don't know if everyone struggles as much as I do to keep track of this actually while they're doing it. I find it very difficult to remember, like, what was the variable? So I always label it like this. Now we're integrating with respect to y, but this is more of a, this is like a Calc 1 integral again. Just make sure you kind of respect the chain rule, right? So for this first one, we're going to have 2/3 because there's a 2/3. When you do u is equal to 9 plus 4y, you get 4 dy is du, so 1/4 du is dy. You need a 1/4, so there's going to be a 1/4. Then we're going to do plus 1 to the exponent, which gives us 5/2, so 2/5, and then our thing to the 5/2. I don't know how much of Calc 1 you want me to explain while I'm doing these videos. There's a lot of videos on how to do integrals. Specifically, I have a video on integrals with radicals, which I think could be helpful in this case. Let's go through this. So you get this, you still have your 1/4. You're going to have your 2/5 again. You'll have this again. And now y is going from 0 to 4, but we don't need to specify y is going from 0 to 4 because it's the only variable. And then we plug in, and this one's just kind of a mess, so I'm just going to do this. Get this is 4 to the 5. So overall, we get this. So I did some stuff there, right? Like what I was really doing was 25 is a perfect square, so I did 25 to the 1/2, which is 5, and then to the 5th, and then 16 is a perfect square, so I did 16 to the 1/2, which is 4 to the 5th, and then 9 is a perfect square, so I did 9 to the 1/2 is 3 to the 5th. I factored out 1/15, and I got that, and then I used a calculator for sure. I did not do that by hand. All right, let's look at number 30. 0 to pi over 4 to pi over 2, cosine of 2x plus y, dy dx. So first with respect to y, then with respect to x. So let's do it. So we still have 0 to pi over 4. Integral with respect to y is going to be sine of 2x plus y. So sine of 2x plus y. And then y is going from pi over 4 to pi over 2. And we still have a dx. So we're going to sub in, which will give us, when you sub in pi over 2, you get this, minus when you sub in pi over 4, you get this. Now we're just going to integrate this with respect to x. So now this is like a Calc 1 integral. I'm going to show the work. So we're going to get negative 1/2 cosine of 2x plus pi over 2. And then you'll get plus 1/2 cosine of 2x plus pi over 4. We're going from 0 to pi over 4. You don't have to write x equals there because there's only one variable. Plug everything in, it's going to look like this. So that's all the steps. And then we need to know the cosine of pi is -1. Cosine of 3 pi over 4 is negative root 2 over 2. Cosine of pi over 2 is 0. Cosine of pi over 4 is root 2 over 2. I'm going to make all those substitutions. Gives us this. And then, I don't know, we just clean it up. And we ultimately end up with 1/2 minus root 2 over 2. I'm happy to explain more about that in the comments if you have a question, but I don't want to take the time in the video right now. All right, number 31. We have from 1 to 2, 0 to 4, dy dx over x plus y. So when it's written this way with dy dx in like the numerator, the one on the left is the one that you're supposed to do first, and then the one on the right is the one you do second. I'm going to rewrite this so that it looks a little more nested, I guess, because I prefer that. But the textbook will write it with dy dx over x plus y, so you do have to know how to handle that. But it makes sense, right? We read from left to right. I think it makes sense. Okay, so we have to integrate this. So first with respect to y, right? So that's our variable. So we basically have 1 over u, which will give us the natural log of the absolute value of u. So we'll get natural log absolute value of x plus y. And then y is going to go from 0 to 4. Okay, so now we substitute that in, and there's still a dx. So when we sub in for y equals 4, we get this. Then minus, we substitute the 0, we get that. So now we have to integrate this. I recommend that you memorize the integral of natural log. That comes up a lot, and it's something that if you know it, it's just significantly easier. So the integral of natural log of u du is u natural log of u minus u, and then plus c. We don't usually need it because we're doing definite integrals. The way that you get it is by using integration by parts. If you want to work it out, you let u equal natural log of u, I don't know, let u equal natural log of x and let dv be dx, and you will get it. So then you just use the formula with u. So I'm going to integrate this using that formula that I have memorized. So it'll be x plus 4 natural log of x plus 4 minus the quantity x plus 4, and then it'll be minus parentheses x ln of x minus x. Okay, and then we have to evaluate this from 1 to 2. And this is like a nightmare to substitute into. So I'm going to do it, or I'll like show the work. So these are the things you get. And then you have to like work some stuff out, I guess. So I've underlined, like, what did I underline? I underlined everything that has a natural log in it, right? So you have a natural log of 6, a natural log of 2, a natural log of 5, a natural log of 1. Natural log of 1 is 0 though, so that's going to be gone. So that'll give us 6 natural log of 6 minus 2 natural log of 2 minus 5 natural log of 5. Then we have everything that's not a natural log, which is all these things. If we combine all of those, we end up with negative 6 plus 2 plus 5, and then there's like minus negative 1. So that's negative 1 again. Overall, that's just 0, so it doesn't contribute anything. So that's our final answer. I actually think some places they'll like combine that using properties of logs, but I just don't want to do that. All right, next problem. Integral from 1 to 2, integral from 2 to 4, e to the 3x minus y dy dx. This one snuck in here. This actually can be written as a function of x times a function of y, so I'm going to do it, right? Because e to the 3x minus y is e to the 3x times e to the negative y. I'm going to separate this into two integrals and then do each of them separately because it's just faster, right? So when you do recognize that, take advantage of it. And then we evaluate, and then we get this, which does not clean up. So I'm going to leave that the way that it is. All right, 33, integral from 0 to 4, integral from 0 to 5, dy dx over the square root of x plus y, which again, I'm going to choose to rewrite. So, I mean, if I were just writing it, I wouldn't write the original problem. I would just write out the nice form that we have on the right-hand side there. So the first integral is with respect to y, and it's pretty straightforward. So think of that as x plus y to the negative 1/2. So you're going to do plus 1 times the reciprocal. We're going to get just 2, and then the square root of x plus y. We're going from y equals 0 to y equals 5, and then we'll take the result of that, integrate with respect to x. So if y is equal to 5, we get this. If y is equal to 0, we just get this. Now we integrate. This is, very much a Calc 1 problem. So we're just, think of it as, always think of radicals as a rational exponent. So square root of x plus 5, think of as x plus 5 to the 1/2. So here we will get 4/3 x plus 5 to the 3/2, and then minus 4/3 x to the 3/2 from 0 to 4. We plug in 4, and we get 4/3 9 to the 3/2 minus 4/3 4 to the 3/2 minus, when you plug in 0, it doesn't all zero out. You get minus 4/3 5 to the 3/2, and then the 4/3 x to the 3/2 will zero out. You have to be careful. Plugging in 0 doesn't universally zero things out. It just often does. This actually simplifies like quite a bit because of all the perfect squares. But then there's this annoying thing where 5 is not a perfect square. So all of the 9 and the 4 to the 3/2 can be simplified. So I'm just going to do it. You can work out why that's true. And then here, you can work out why this is true. And then this will not simplify. So, it's like you're so close to getting a really nice answer. And then there's that 5 to the 3/2. So overall, we get this is our answer. All right, I'm going to do 34 and 36. 35 will be its own video. And when you watch the video for that, you'll see why. All right, integral from 0 to 8, integral from 1 to 2, x over square root of x squared plus y dx dy. So first we're integrating with respect to x. I'm going to rewrite kind of the integrand, I guess, with respect to x. So the first integral that I'm doing really looks like this. X quantity x squared plus y to the negative 1/2. I need to integrate this. So because x is the variable, there should have been a 2 by the chain rule, so a 1/2. And then when you add 1 to the exponent, you get 1/2. The reciprocal is 2. And then you will get the thing, x squared plus y, to the 1/2. Okay, and then technically plus c, but we're doing a definite integral. So that's the antiderivative with respect to x. So I'm just going to sub that in here. So integral from 0 to 8 of just the quantity radical x squared plus y, because all of that simplifies down to radical x squared plus y, right? 1/2 and 2 cancel. To the 1/2 is, I don't know why I don't leave it to the 1/2, because I'm just going to, like, in my mind, change it back to that. But x is 1, x is 2, which makes this a little uglier than maybe it could have been. And then there's going to be a dy. So when we plug in 2, we get this. When we plug in 1, we get minus this. Now we're going to integrate these. There's no chain rule to worry about, so we just do plus 1 times the reciprocal. So we're going to get 2/3, 4 plus y to the 3/2, minus 2/3, 1 plus y to the 3/2. Y goes from 0 to 8, but there's only one variable, so we don't have to label it. Plug everything in. You're going to get this when you plug in 8. You're going to get this when you plug in 0. And then this, like, kind of simplifies, but also, like, not great. So these are the things they simplify to, which ultimately gives you this. And then if you want to know, like, 12 to the 3/2, you can mess around with and make it just 4 to the 3/2 times 3 to the 3/2. Then 4 to the 3/2 is 8. And then 3 to the 3/2 is 3 root 3. So that's where this weird 16 root 3 came from, because I rewrote 12 to the 3/2. Okay. So 35 is its own special beast. I will come back in the next video and do that. I'm not doing it here. It's going to take way too long. 36, last one in this video. We're going from 0 to 1, 2 to 3, quantity x plus 4y to the -3rd, dx, dy. So first, we're going to integrate with respect to x. So x is the variable. There's no chain rule nonsense going on, so we're just going to have plus 1 times the reciprocal. So -1/2 x plus 4y to the -2nd. And then x goes from 2 to 3. And then there's still a dy. So when we plug in 3, we get this, minus when we plug in 2. So minus -1/2 becomes plus 1/2. And then 2 plus 4y to the -2nd. This will be integrated with respect to y. There is chain rule to worry about here, right? Because you have 3 plus 4y. So there should have been a 4, so a 1/4 will show up. So we have this -1/2, a 1/4, plus 1 times the reciprocal. But the exponent's -2, so when you add 1, you get -1. So really, we just end up with -3 plus 4y to the -1st. Same sort of thing happens here. So we're going to get plus 1/2. There should be a 4 by the chain rule, so a 1/4 to balance it out. And then you'll get negative this to the -1st from 0 to 1. When you plug in 1, you get this. And then minus, when you plug in 0, it doesn't zero out. We get this, which, like, I don't know, you take a 1/8 out of everything, and you would have this. And then I use a calculator for this. I got 1/56. Okay, so that ends part 2 of this assignment. I'll be back in part 3 to do just number 35. So I hope this was helpful, and I will see you there.